Hi everybody, it's Miss Austin, and I'm going to be doing the key for the completing the square worksheet. Here we go, just getting it loaded up. All right, here we go. So we are running across quadratics that cannot be solved by the by factoring or the square root method. So we've learned a new way today called completing the square. So we kind of trick the problem into being a problem that can be factored. So we have to figure out what number would go here. Okay, you can do it in your head, but you can also do the box, right? Didn't really leave a lot of space, but right? You know that x times x made x squared. You split this in half. That's 6x and 6x, which would have been 6 and 6. 6 times 6 would be 36. If this was 36, this would be a perfect square. So I need this to be 36. Number 2, use the box to help. X times x makes x squared. Split this in half, negative 7x, negative 7x. I'd make negative 7, negative 7. So that number in the far right corner would be 49, negative 7 times negative 7, if it was a perfect square. All right, number 3, there's already something there. So what number would I have to add in order to make this a perfect square trinomial? No big deal. So we can move this over here by subtracting it, okay? And we can figure out how this number that we add affects that later. But again, kind of making a tiny one. X times x makes x squared. Split this in half. That's 9x and 9x, which is 9 and 9. So 9 and 9 makes 81. This needs to be 81 right here to make a perfect square trinomial. Number 4, there's already something there. I'm going to move it over by subtracting it and figure out what would I need to put here to make this a perfect square. X times x makes x squared. Cut this in half. You have negative 5x, which is negative 5 and negative 5, which would make 25. I need to add a 25 here to make this a perfect square trinomial. And the reason we want to turn it into a perfect square trinomial, just real quick, like if we look at this one, is because instead of writing it like this, I can look over here at this box I made, right? This is actually x plus 9 times x plus 9. But instead of writing it twice, I can just write it once with a squared equals, and then there'll be something over here. And oh my goodness, look, I can solve this by the square root method. It no longer is something like this that has to be factored to be solved. I can take the square root of both sides. Okay, so this is the strategy. All right, so now we're going to go ahead and put this all together and actually solve the quadratic. And it looks like number 5 is already this problem that I've already started. So I've already done the box up here. So I know I'm going to subtract 71. So I have x squared plus 18x. I'm going to leave a little space equals negative 71. We already know up here that I need 81 to make this a perfect square trinomial. So I'm use a different color. I'm going to add 81 to this. I'm allowed to do that as long as I do it over here to maintain equality. Okay? Now again, why would I want to do that? Because now I can rewrite this like this. X plus 9 times x plus 9, or just x plus 9 squared, equals, now I'm going to clean that up, I get 10. Now this looks like a problem we've been solving for weeks, right? I know that if I take the square root of this side and the square root of this side and do my work over here, I know that x plus 9 can equal the positive square root of 10, or x plus 9 could equal the negative square root of 10. And now I just need to get x alone. I'm going to subtract 9. So this answer is negative 9 plus the square root of 10, or negative 9 to both sides, negative 9 minus the square root of 10. Now I do want to show you real quick how you can check these. So if you can figure out what the decimal is for this, of course Miss Austin has no calculator on her here. Okay, well, let's see what we could do. Let's go get a calculator. Let's go to Desmos. So I want to show you how you can use Desmos to check your work at home. So first of all, I'm going to see what this number is. Negative 9 plus the square root of 10. That's about negative 5.87. I'm going to write that down on my paper here. I know you can't see it right now. Negative 5.84. And then up here, what's negative 9 minus the square root of 10 is about negative 12.16. Now, if I did it right, when I type in the original equation, this is where it should be crossing the x-axis. I found the roots, right? I found the zeros. So now, if I go over here and type in the original equation, it was x squared plus 18x plus 71. Oopsie daisy. Oh, I did equal 71. I was like, what? Start this video over. Okay, now look. My answer should be those two numbers, right? Negative 9 plus the square root of 10, which we figured out was about negative 5.8. Look at it. And negative 9 minus the square root of 10, which we wrote down as negative 12.16. I'm right. Desmos isn't going to leave those as exact answers. We're going to leave them exact, but Desmos is going to have them as decimals, so that's why I switched it, right? So I typed that into Desmos, that's what it was. I typed that into Desmos, that's what it was. Then I typed this in to see where does it touch, and if I'm right, it better touches at those numbers, right? Those are just approximations. This is the exact answers right here. Okay, here we go. Number 2 is the same as number 4, right? We already got it started. Look, I already know I need to add 25 to both sides. Okay, so here we go. We have x squared minus 10x. I'm going to subtract the 6 over here, and I'm going to leave some space. We know, look at your box, if to make this a perfect square, this needs to be 25. So I'm going to add 25. Whatever I add to one side, I add to the other to maintain equality. Why would I want to do that? Because now instead of writing it like this, look at the box. This is x minus 5 times x minus 5. That's what makes all this. So now I can write x minus 5 times x minus 5, but instead of writing it twice, I can just write it once with a squared, which will help me solve it easily. Equals, now I'm going to clean that up, that makes 19. Now remember our work from lesson 6 through 9. This is an x squared. It's got two answers. There's two numbers you can square to make 19. So when I take the square root, I know that x minus 5 could equal the positive square root of 19, or x minus 5 could equal the negative square root of 19. Now I've just got to get x alone, so I'm going to add 5. So the first answer is 5 plus the square root of 19, or 5 minus the square root of 19. And again, how do you check your work on Desmos? We're going to switch these into decimals and go type it in. Let's go try again. Let me show you one more time. So this time, what's 5 plus the square root of 19 is about 9.36, and then 5 minus the square root of 19 is about 0.64. So now let's type in that problem that we got for number 6. X squared minus 10x plus 6. We want to know, when does it run into 0, right? That's what the original problem said. It better be those two numbers that we just approximated. 0.641 and, whoops, sorry guys, 9.36. Very good. That's exactly right. That one was 9.36. That one was 0.64. We were finding, where does this run into 0? But we did all kinds of stuff to manipulate it to make it easy to solve. All right, here we go. Number 7. We don't have any legwork done on this problem like the first two. So I need to figure out, I've got to trick this problem into being a perfect square. So first thing I'm going to do is I'm going to minus the 1 over here. And I'm going to leave a little space. Now I'm going to go ahead and do my box. Some of you might be able to do this in your head, right? You split this apart, 2x, 2x. So this is plus 2 plus 2. So this should be 4. I need a 4 here to make this a perfect square. Right? There was a 1 there. It wasn't factorable, right? We're manipulating the problem. So I'm going to add 4 here, but whatever I do to one side, I do to another. I'm adding this number to both sides. Why would I want to do that? Because now look, instead of writing this, I can write it as x plus 2 times x plus 2. This is actually x plus 2 times x plus 2, or x plus 2 squared, equals, clean this up, what do you get? 3. Now I can solve this, right? This can either be the positive of this or the negative. So I know x plus 2 might have been the positive square root of 3, or x plus 2 might have been the negative square root of 3. I'm going to subtract 2 from both sides. So this answer is negative 2 plus the square root of 3. Right? That's a number. It's just you're adding those two together, but you have to leave it like that because you can't add a negative 2 with a radical. Negative 2. Well, I mean, you can, but it wouldn't be exact. We'd have to round it, which is what we're going to do on Desmos. All right, let's go check. So first, let's figure out what those numbers are. So I have negative 2 plus the square root of 3, which is about negative 0.27. And then negative 2 minus the square root of 3 is about negative 3.73. Okay, I recorded those on my worksheet. Now I'm going to go type in the original problem, which was x squared plus 4x plus 1. And it better be touching at negative 0.27 and negative 3.73. Ding, ding, ding. Winner, winner, chicken dinner. All right, last one. Right now, I mean, by the way, we're assuming none of these problems are factorable, but, you know, we probably didn't make it so you could factor it. But there's always a chance one of your old strategies works without all this work, right? But we're going to just keep completing the square. So here we go. I'm going to subtract 50 over here because right now this is not a perfect square, right? This doesn't factor to the same thing twice. So we're going to figure out what number would need to be here to make it turn into a perfect square trinomial. So here we go. X times x makes x squared. You break this in half, which is negative 8x and negative 8x. So this is negative 8 and negative 8, which means this should be 64. This is what I need here to make it a perfect square. But whatever I add to one side, I add to the other. Why would I want to do that? Because now look, instead of writing it like this, I'm going to write it as x minus 8 times x minus 8. This is actually x minus 8 times x minus 8, or x minus 8 squared. Can you skip this step and go straight to that? Yeah, if you understand that, right? But you might want to do it out a few times so your brain understands what's going on. Negative 50 plus 64, 14. Now I can solve this quite easily, right? I'm trying to find out what numbers make this equation true. It wasn't factorable, so I'm tricking it into a problem that can be solved by the square root method, which is called completing the square. So I know this could be the positive square root of 14. I'm going to do this over here. X minus 8 might be the positive square root of 14, or x minus 8 might be the negative square root of 14. So now I just got to finish solving these. Add 8, add 8. So one of the answers is 8 plus the square root of 14. And the other answer is 8 minus the square root of 14. All right, last check here. Let's go to Desmos. So first, let me see what those numbers are. So I have 8 plus the square root of 14, which is about 11.7, and then 8 minus the square root of 14, which is about 4.26. Now let's type the problem in. You might wonder, why are we wasting all our time doing this? So we can actually understand what we're doing. We're finding where the original quadratic crossed the x-axis when it was equal to 0. Solving it when it was in its original state was nearly impossible. So we used a strategy called completing the square. So 4.26 and 11.7, which is what those two numbers were. Let's go back and look. I typed that into Desmos. That was at 11.7 and about 4.26. Okay? So this strategy is called completing the square. When you cannot solve a problem by the square root method when you first come to it, or you cannot solve a problem by factoring when you first come to it, another method is what we practiced today, completing the square. I hope this helped, and I'll see you soon.